All right, this is an air compressor repair, and basically when you plug it in, nothing was happening. So the first thing to check was the, I guess, main electronics box, which is underneath this little black box I'm trying to get to. Turns out it was covered by the tape with the fuse that it had up top, and with a simple Phillips screwdriver was the way to take off that box. Once I figured out that that is where the screw is, taking off the box was easy. And underneath the box, you'll see that the red switch, it's actually a holder for this momentary switch that's there, this black tab that basically turns on and off the or breaks the contacts. So it's the main switch that'll connect the 120 volts to the other side. And so the first step was to make sure that we were getting 120 volts AC on the other side of the switch, which was done with this voltmeter set to the AC voltage setting. And as I ohm out the side, those are the connections there, so getting 120 volts. And then the opposite end had similar connections that start going to the motor in that big black box. Switch is working, so now it's time to look into the box. Alright, with the cover coming off with 4 screws, the first thing I wanted to check is to see if the fuse on the other side actually was good. And just make sure you set the voltmeter to the right setting, because I was looking at voltage and not continuity. So once I got that checked out, I actually turned the knob and we can see that the fuse was actually good. As we got a power strip to basically make it easier to turn on and off the unit from just plugging it in, we got that set up and started doing some more voltage checks on the board. Basically, the voltage on the board was getting 120 volts, which was good. But then we had to troubleshoot, I guess, what was on the board. And you'll see me kind of checking the different voltages at different spots just to make sure we were getting 120 volts AC. Now you can see the board a little better, and I'm trying to follow the path and trying to check all the signals and see what's going on. We did discover that there was a yellow capacitor on there. That's sometimes a source of problems and may actually still be the issue with this unit, as well as a what turned out to be a bridge rectifier, a 4-pinned item to help a collection of diodes to help make the AC voltage turn into DC voltage. So to get a better look, we took off the circuit board. With the board loose, we were trying to read the basic circuit board that was on there, and also trying to figure out if there's any other areas that we could inspect. Moving the motor was a bit rough, but still plausible for moving. Not like it was any obstruction in the brushes of the motor itself to turn, so that seemed okay. As we were checking out some other parts of the board, it's important to note some safety item, and you'll see it soon. Be careful when everything is plugged in, because you can create an arc if you're not careful with your probes. So make sure you have proper safety gear like eyewear and stuff like that when working with live electricity.
How's that? Is this thing going to be fixing? Oops. We have voltage. Okay, that's a good sign. It's not real electrical.
As I recheck all the voltages after the spark, I just want to make sure everything is, back to where it was. What happened was the 2 leads were actually very close to each other, so when I kind of slid the probe, I actually, put a piece of wire between the high voltage ends, and that's where the current jumped and caused that arc that we saw. Actually kind of melted the tip a bit. on my probe, so always be careful. While we did this too, we also noticed that the fuse was blown as well, so current must have also came through that end as well. So the fuse kind of did its job and broke, but now we need a replacement. Now for the rest of this video, we ended up trying to get deeper into the motor, since I guess that was suspect, but we didn't have much luck. It looks like the two screws that we had put together, the that holds the motor in the front, didn't allow the motor come out to further examine the board and the wires that are inside the motor. And on the back side, you'll see the I guess the piston crank cover. That also didn't give access to the other side of the motor. There was no other screws in there to remove the motor housing, so we couldn't get deeper into the motor, which is probably the cause of this issue. But looking at the board and doing research, the bridge rectifier actually takes the 120 volts AC and then outputs 120 volts DC. We also tried to check the capacitor a few times. It may have had a charge. It's hard to 100% tell. I guess in reality we probably should have desoldered it from the board and tried to check that, but again, we don't have any replacement capacitors on hand to fully fix that if that was the case. So you'll get to see the rest of the assembly, or rather disassembly, of this air compressor, but we were not able to get it running despite our efforts. So in the end, we ended up just putting everything back together for the customer, and then I guess they decided that he'll use it maybe for some spare parts later on in the future, which was a shame. It does look like this unit could be repaired. It seems like a fairly robust motor, but we couldn't get access to it, and internet research didn't yield any results on this model. So not too much else that we could have done, since it was hard to get any other troubleshooting information on it. The motor itself didn't have any labeling that we could identify, so we were also at a loss there as well. Hope you enjoyed this video, and not all of them are successful, sadly, but hopefully this can help you if you're troubleshooting your air compressor.